we're going to walk through a tutorial on how to tune a model predictive controller. And in order to do that, we need to understand the objectives of the controller and what terms to change in the standard MPC form. So we have two different types of objective functions. I'm just going to label this one 2 because this is going to be a squared error, okay, where we have an error that's going to be squared, and that's going to be, this is going to be our model value minus a target. And we're going to square that. Okay, and we can see that term right here in matrix form. Okay, we can also use an L1 norm. I'm just going to write that as my number 1 here, and it just changes how we do this objective function term. We're going to go through this example and show all of these different tuning values right here for the L1 and the squared error as well. They're going to be fairly similar. The only difference is that you're changing this term for this term right here. Okay, so let's go get the example for this. We're going to go to the dynamic optimization course. So just come to APMonitor.com. You can select take a course and then browse to the dynamic optimization link. Come down to on the right down to control and select the control objectives. And so this is where we're going to find the same information I showed you there, in addition to this example problem that you can download. So I'm going to do save as and save it on my desktop, and then go ahead and close this. Okay, and let's go get that these files right here, and I'm going to extract them. So right click and then extract the files. I just go ahead and discard the zip file so it doesn't so you don't end up running something like that. Something in there. Okay, so there's the Python and the MATLAB version of this exercise. I'm going to use the Python version. The MATLAB is very similar. Okay, and I'll put it over here and make it just a little bit bigger. Okay, so we have a model predictive controller here, a fairly simple model. Let me go ahead and open that up, where we have some parameters, a couple of variables, and a couple of equations as well. Let's go into our script, and we'll see that our k value is a parameter. Our manipulated variable, the one that we can change, is the u value. We just have a state variable, the one that we observe but we don't necessarily control with that x, and then y is going to be our controlled variable. So let me just change one thing here. I'm going to change, if you want to go through this, the set point high and the low for the controlled variable. Go ahead and change that between 30 and 20. That'll widen the gap a little bit on our target for our controller and just show us a little bit better what we're doing. So go ahead and run this, and either MATLAB or Python, you should get the same result. And select down here at the bottom, go ahead and select this Y trend right here, and then we can see the target values. It went between 30 and 20 at the end. And you can also see the trajectory there of what it was trying to follow. Okay, so let's go in and start tuning this now and discuss some of the objective function terms that would give us, one answer or another. Okay, this is the L1 norm where it has an upper set point and a lower, and it doesn't penalize anything that's inside this this dead band here. Okay, but if the model prediction were to come up here, for example, it would try to use the manipulated variables to drive it back into this range. So this is a common form for an objective function. And let's go now to our okay, so I'm going to come back over here, and here are my set point high and low, and the first tuning that we can do is this one. So I could change this, for example, to 10, and that would slow it down. This is the time constant for the controller. Okay, and so the prior one, is here. The new one is okay. So let's see if this slowed it down a little bit. Go ahead and select your Y value again there. Okay, so you can see it slowed down the response on these black lines here, the trajectory. So it went from a time constant of 5, which was a little bit steeper there, to something that's a little bit more gradual. And you can see that the controller was successful in driving it to somewhere in between these two. But now let's say we wanted to try to minimize y. Okay, we wanted to hug the minimum value here instead of being somewhere in the middle. Okay, so let's come in here and we're going to change one option. Okay, we're going to do y dot cost, and we're going to set that to something like 0.1, and this is going to add a term to our objective function, and this is our y dot cost. So it's going to try to minimize. It's going to try to minimize this term right here. Let me zoom in just a little bit more. It's going to try to minimize this term. Anything that's multiplied by y, it's going to have a positive value there, so it's going to try to minimize that. Let's run it again now. Okay, so after you've changed that, it's going to ask you if you want to save it, and go ahead and click yes or OK. And then we're going to have another solution that'll pop up. And again, well, here you can select y, and then you'll see that it tried to minimize this. Now it went right here at the very bottom and tried to hug that lower line. Okay, let's change that to maximize it now. And so let's go to negative 0.1, save it again, and then run it. And let's look at our web interface. Just go ahead and select that plot. And yeah, you can see that it's trying to maximize. Okay, maximize the y value to the upper limit of our trajectory. Okay, so now that's called controlled variable tuning. But another common way is for tuning model predictive controllers is called move suppression factors, or we're going to be doing manipulated variable tuning as well. So let's go ahead and take off this, the cost here. Okay, now we're going to come up to our manipulated variables, and we have two parameters here that we can use. We can use u.cost and u.dcost. So let me go back to the objective function form right here. So this one right here is going to be u.cost. And so if I have a positive value here, it's going to try to minimize it. If I change it to a negative value, then it's going to try to maximize that value. Okay, and then we have another one right here, and this is going to be u.dcost. And again, if I have positive, it'll minimize it, and negative, it'll try to maximize it. So let's go back to our application and change both of these. This one is a move suppression factor. Okay, and then this one on the left, this one is just to max or minimize the value. So for example, if this was fuel or something like that, we might want to try to get within our target range, but with all else being equal, we want to try to minimize the fuel consumption. So that would be one example. Okay, let's go back to our application now. Let's change the dcost. We already had that at 0.1, and then the cost is 0.1 as well. And let's go ahead and try to optimize this. We'll run it. Okay, so it ran again, popped up a web interface, and then just go ahead and select the the y value here for the plot. And you can see I'm trying to minimize the u value, so it also minimized the y value in the end. So there's my u profile. Now you can select those plots from any of these hyperlinks that are right here. Okay, and let's go back here again. I'm going to change the cost to negative 0.1. Okay, this is manipulated variable tuning. And then let's say I also, let's run that, and you can see that it's going to try to maximize u, and then it'll also correspondingly maximize y. Okay, there's my y value, and then if I come down here to my U value, you can see that it tried to maximize that. So that was a secondary objective. It was within that deadband, but it saw that it could get a better objective by trying to maximize U and Y. Okay, let's go, let's turn up the move suppression factor until it just really incapacitates this controller. Okay, so I'm going to go ahead and get rid of that option, and let's set this DCOS to 10,000. So let's see what it'll do now. Okay, so we have a very large move suppression factor on our manipulated variable, and we should see that it doesn't do anything. Okay, so we basically set that DCOS value so high that it said, hey, it's not worthwhile to move my U value. So it effectively just shuts it off. Okay, so that's a move suppression factor. So you don't want to make that too large so it starts competing with the objective function that we're trying to drive to a certain set point. Okay, now we can overcome that if we say, if we change the other parameter in our objective function. So let's go back. This is our final, these are the final ones. Right here, these are going to be right here on the left, an error on our trajectories is going to be weight set point high and a weight on the set point low. Okay, and we can change that to increase their importance as well. Let's see their default values. If we come back to the web interface, and then if you just come to the CVs tab, okay, you can see all of the attributes of that Y variable, the controlled variable. We're going to go down and you can see the set point low and high. If you put your mouse over it, it'll give you a little tool tip. You know, the status, for example, we changed that on or off. The tau value was 10, and that's a time constant for controlled variable response. We're also going to come here to the weight set point high and weight set point low, and there the default is 20. Okay, so let's change that. Let's we had such a high move suppression factor. Now we want to dial up the weight set point high and weight set point low. I'm just going to copy these two lines and just change, add a W in front of those. Those are the weightings. Okay, and let's just say 1e to the 8th. Okay, so these are very high priority, 1e to the 8th. And these can be different. Okay, so 1e to the 6th, for example. And so we don't want to violate the upper limit, but it's a little more acceptable to violate a lower limit, for example. Okay, so let's see what this did. It may still be, oh no, it worked well that time. Okay, so the weight set point high was able to overcome that very large DCOS value that I had right here, the penalty for the MV movement. Okay, and so tuning is all about the relative amounts of these tuning values that you put in. If I come back here, so it's all kind of relative. If you have this one as a very large one, 1e to the 8th, and this one you know, might be 1,000 or 10,000, then this one is going to win because it's a higher weight. Okay, so where you have just one objective function and you're changing the values in that objective function. Okay, let me just cover one other thing briefly before we move on to the next topic, which is the squared error objective as well. And this is, you can change how this trajectory, these are the reference trajectories. Okay, reference trajectories, and you can change how those are going to start. You may just want a pure deadband. So right now we have a reference trajectory that takes us up to the new value, okay, but does it in a controlled manner. You can change an option here to NLC and trajectory init. Okay, so this is how the trajectory initializes itself. If you set it to 0, it's just going to be a pure deadband. So let's go and run this again, and let's see what it looks like if I changed it to, okay, I may have had that Oh, you know what? Let's go back in and let's just verify why this wasn't working. Okay, so if I come into the CVs, it's actually a CV property, so you can change this on CV by CV type. So I need to change this one, the y dot trnit, to equal 0. So let's go back in here. I made a mistake on that. So it's by CV type that you can do this, and just change that to y dot trnit. Okay, and I'm going to change these back to 100 and 100, and then the dcost, I'm going to set that back to 0.1. Okay, so let's go back to run, and it's going to then optimize again. Now this is changing it to a pure deadband. So it says instead of starting here and then coming up at a gradual rate, it just says I want you between this upper and lower limit and get there as fast as you can. So it does it within just a couple points, and it's within this trajectory deadband. Okay, now what I want to do is switch over to the squared error version. So let's come back to the sheet. We've covered this L1 norm, which is kind of like an absolute value. Okay, it's kind of like an absolute value, but instead of doing it with absolute value, that would give us a non-continuous differential or a derivative value there. It's -1 slope here, and then +1 here, and it creates a point right there at which there's a discontinuous derivative. So d absolute value of x dx is going to be discontinuous right here at x equals 0, and that doesn't work very well for solvers, so we have to formulate it in this way with slack variables. Okay, so it just adds a couple additional inequalities that allows effectively a continuous derivative approximation to the absolute value operator. Okay, let's get back to the squared error, because this one's actually a lot easier to understand it. It's probably more familiar to more users. This one, it has these same three that we just talked about. This is our u dot dcost. Okay, here is our u dot cost. And then this one right here is going to be our y dot cost as well. Okay, and then here, instead of a weight set point high or low, we just have a weight set point, because we only have, let me get rid of the h. You just have a weight on our set point because we don't have a high and a low limit. We're just trying to drive to a certain trajectory target. Okay, and there's going to be a squared error for penalization from that squared error target. Okay, so to change it to a squared error form, you just have to change one parameter, and that is going to be this one, where it's going to be CV type. So if you change it to a 1, that's going to be a L1 norm. That's what it is by default. If you change it to a 2, that's going to be a squared error. So if I run this again, okay, it's going to pop up another web viewer, and there is my trajectory. I have a this 0 value here. I didn't set my set point yet, so I need to go back in and change some of these things. So instead of set point low, set point high, now I just have a set point. And instead of a weight set point high and weight set point low, I just have a weight on my set point. Okay, because I got rid of the L1, and now it's a squared error. Okay, and now if I change that back to 2 for my trajectory initialization, that's more of a trajectory that starts from the current value and then rises to the set point with the time constant 10. And there again, I still have my upper and lower values on my u value, and there's a slight decost as well. Okay, so let's go ahead and run this one again, and it's going to ask me if I want to save it. Go ahead and click OK. Okay, and let's see this one. Okay, so here is my reference trajectory now. You can see it essentially follows it the whole way. Just right here, just at this first period right here. There's a little bit of a deviation, but they're essentially on top of each other the rest of the way. So the black is the track or the trajectory that I'm trying to follow, and the purple and the blue is right underneath it, is the model value that it seeks to, that it's driving there. Okay, there's my U value right there. Okay, and then you can do the same things with dcost or these others, costs as well. Okay, just a couple other tuning ones I want to talk to you about. Now this is more of the I just talked about the objective function today, but you also have other tuning values that you can put into the application. And if you go to controller tuning right here, it'll tell you some of the most common parameters that you can change for your controller. And again, there's more content there about manipulated variable tuning and controlled variable tuning. Okay, so this was kind of a deep dive into the objective functions for the model predictive controller, both the squared error and the L1 norm. We went through an example to show how as we change those values, we get a different result. And so a lot of the tuning that goes into an application is either manipulated variable or controlled variable tuning. You're going to have specific objectives, like I want to keep this value within a certain range. I want to try to maximize or minimize it within that range. I might not want to have too much movement on my manipulated variables. So you got to translate these natural language expressions into a mathematical statement of what you're trying to do, and you can do that by expressing it in this this objective function. The other thing that I'll mention too is you can also add other things in your model directly. Like you could minimize, let me just type minimize here, and then x minus 2 squared. So you can also add your own terms to the objective function right here in the model. If you declare a parameter or a variable as a controlled variable or a parameter as a manipulated variable, then you get those equations automatically added to the application for you, or you can just do it yourself, like this one down here at the bottom. Okay, so I hope this is helpful. I'll post this video online and put it with the rest of the content that's here under the control objectives, okay, for the dynamic optimization course.